Okay, for what we have in the first problem, it says suppose that the function h is defined for all real numbers as follows. And here we have a piecewise defined function where h of x is equal to 1 if x is less than negative 1. And we have that it is equal to the square of x plus 1 followed by the subtraction of 3 if x is between negative 1 inclusively and 2 exclusively. And we have that h of x is equal to 1/2 of x plus 2 if x is greater than or equal to 2. And it says to find h whenever x is set to negative 4. Okay, so we have for h of negative 4, and in terms of where we're going to have negative 4 to be situated, okay, so we have that negative 4 is less than negative 1, so we have, in consequence, we have the h of negative 4 is equal to 1. Now for h of negative 1, okay, negative 1 cannot be less than itself, but it is equal. So we have for the compound inequality, we say that negative 1 is less than or equal to itself, which in turn is less than 2. Okay, so that is going to be a true statement. Okay, so we have for h of negative 1, okay, that is equal to negative 1 plus 1 squared minus 3, okay, and so this will come out to minus 3. And for h of 0, okay, now 0 is between negative 1 and 2, so to say that negative 1 is less than or equal to 0 is less than 2, okay, that is true. And for h of 0, okay, so you have 0 plus 1 quantity squared, and we have minus 3, and 1 squared is 1 minus 3, which comes out to negative 2. So in checking the results here, okay, so we've got 1, negative 3, and negative 2, and upon checking the results, and that is correct. Okay, for this item, it says to determine the intervals on which the function is strictly decreasing. And it says to write your answer as an interval or as a list of intervals. Okay, so where we have decreasing, this is where we have downward motion. And for what we have in this particular image, so you have decrease here, another decrease at the far right. And for the activity, so we're going past negative 3 at x, approaching negative 1 as well. So for the activity of decreasing, we're going to have parentheses as grouping symbols. Okay, so you have negative 3 to negative 1. And then we have for the next case, so we put a comma here. And then we have for the next decrease, we have going past 4, approaching 6. And checking the result in this case, and the answer is correct. Okay, and for what we have for this item, it says here is a graph of the function f. And it says to use the graph to find the following, and it says if there's more than one answer, separate with commas. Okay, now for all local minimum values of f, okay, this is where we have the dips, so to speak, and we have in this particular case, right, so we have a bottoming out, and this will be where y is at negative 3, and also we have another bottoming out where we have y is going to be at 0, and values at which f has a local minimum. You're going to put in your x values. Okay, so we have x at negative 2, and this is where we have y to be at negative 3, and where y was at 0, okay, we had the x value to be at 3, and so we have upon checking, and the result is correct. Okay, now we have for this side, we have a piecewise defined function, and it says to suppose that the function f is defined as follows. Okay, so we have f of x is equal to negative 1 if negative 2.5 is less than x, which in turn is less than or equal to negative 1.5. So at x at negative 2.5, we have an open circle. Okay, and I have to click on this twice, and moving this, so you have negative 2.5 whenever y is at negative 1. And then we have less than or equal to negative 1.5, and this is whenever y is at negative 1. And if I connect Okay, it says place first point, then placing on the second point. Oops. Let me try this again. Say placing on the first point and placing on the second point. Okay, so I have this line segment, and then we have that f of x is equal to 0 if negative 1.5 is less than x, which in turn is less than or equal to negative 0.5. So we have an open circle at negative 1.50, and then you have a closed point at negative 1/2 and 0. And connecting with the line segment. So I have on the first point, then the second point. So I have the next line segment. And then we have f of x is equal to 1 if negative 1/2 is less than x is less than 0.5. Okay. And so for what we have in this one, so you have two open circles. And this would be at y is equal to 1. And placing on the first point and then the second. So you have this next line segment. Then we have y is equal to 2. Okay, and so we have x equal to 0.5. And then we have x is less than 1.5, so I have an open circle. And then joining, we have with the line segment, okay, so placing on the first point, and then on the second, so I have this portion, and then y is equal to 3 if 1.5 is less than or equal to x, which in turn is less than 2.5. So 1.5 is less than or equal to x, so at x equal to 1.5, we have a solid point. And then for x is less than 2.5, so I'm going to have on 2.5. And then you have y is equal to 3, so I'm going to form a line segment basing on the second point and checking, and the result is correct. Okay, it says, suppose that the function f is defined for all real numbers as follows. So you have for the first, we have f of x is equal to 6 if x is less than negative 4. Okay, so just plotting some points here. Okay, so anything before x is less, or say anything before x is at negative 4, and we have y to be at 6. So I'm just going to plot some points here. So we have at y is equal to 6. So I have like maybe negative 10, 6. And say like maybe negative 6, 6. And we have an open circle at 4. And if I were to take what I have here and establish this line segment, so I click this twice and placing second point. Okay, so I have this particular strip. Now we have that f of x is equal to negative 10 plus x squared if negative 4 is less than or equal to x is less than 4. So we have here, okay, so if x is at negative 4, so I'm going to have negative 4 squared is 16, negative 10 plus 16 is 6. So we have this whole plugged in. And then we have, and following through, okay, so if I were to include other points, so I have here, okay, so we've got, in this case, all right, so we have for x at negative 3, let's say, so you have negative 10 plus 9, okay, so that's going to be, in this case, you have negative 10 plus 9 is going to be negative 1, so you have a point. And let's say we have at negative 3, negative 1. Okay, and so for what we're going to have here. So you have -3, -1. And if we go out to -2, we got -10 plus -2 squared, so that would be -6. There we go. And we have, let's say that x at 0, so that would be 0, -10. And just throwing in some other points. Okay, so 2, let's have 2, -6. And 3, -1. And if I take what I have for the parabola, so placing the vertex and choosing how the curve goes, placing another point, we do this. Okay, so you have placing the vertex, choosing how the curve goes, placing another point, okay, so we got the parabola. Now, I'm not going to have this to run continuously. So we have, in terms of cutting, okay, so I'm going to cut out at -4, 6. And then just cutting. And you'll use the eraser here. So I'm going to erase this top layer. And then we'll do likewise at 4, 6. Okay, so in this particular case, so I'm going to cut once more. So we have at 4, 6. And then applying the eraser. So this will go out. And now at 4, 6, I'm going to have an open hole. Okay, and okay, so we try this again. So we have at 4, 6. Okay, so you have an open hole. And then for x is greater than or equal to 4, okay, so you have 2 times 4 is 8, minus 2 is 6. So I'm back to plugging this hole. And then we have 2 times 5 is 10, minus 2 is 8. And we'll go once more. So 2 times 6 is 12, minus 2 is going to be 10. And just connecting. So you're going to have this line segment to go out continuously. And let's see. I'm going to get rid of this point here. And in terms of whether the function is continuous, and it does run endlessly thanks to the holes that were plugged in. So we have, in this particular case, the answer is yes. So upon checking, and the result is correct. Okay, it says that 3 functions are given below, and it says that for each to decide whether it is an even function, an odd function, or neither. And we have for the first of the functions, now we have f of x is equal to 1 over 2x cubed. Okay, so again we have f of x is equal to 1 over 2x cubed. And if I change the input from x to negative x, so we have 1 over 2 times the cube of negative x, and the cube of negative x is going to be negative x cubed. And this will translate out to minus 1 over 2x cubed. And these values, okay, they're going to have opposite signs. Okay, so f of x is going to be an odd function. Now, for what we have in the case of g of x, okay, so g of x, we have the cubic root of 9x squared. And in terms of what we have once again, so we have the input x, resulting function, again we have at 9x squared. And for g of negative x, so we have the cubic root of 9 times, okay, the square of negative x. Square of negative x is going to be a positive x squared, so this will be the cubic root of 9x squared. And so we have here, these are going to be the same. Okay, and so that is going to be an even function. And for what we have in the case of h of x, okay, so we have here for h of x, okay, so you have x times the absolute value of x plus 7. Okay, so just taking what we have here, so you have h of x. Okay, so we have x times the absolute value of x plus 7. And for h of negative x, okay, so this would be like negative x times the absolute value of negative x plus 7. Okay, and for what we have here now, in this particular layout, okay, so negative x plus 7, x plus 7. Now these are different from each other. However, okay, we have x and negative x, so we don't have the same, and these are not opposite either, because you cannot have the negative of the absolute value of x plus 7. And okay, so in this case, h of x is going to be in the neither category. Again, g of x, okay, we have to be an even function. And again, f of x was an odd function, and checking the result, and that is correct.